Hi everyone, today I'd like to make a video that will serve as a sort of introduction to Docker. We'll be talking about a bunch of key concepts that go with Docker, as well as building a sort of foundation to help you understand what Docker is, what a container is, and why we use them so heavily in the software industry today. Now, in order to understand Docker, we need to go over some of the key things that it's going to try to solve. And to do that, let's first begin at the server level. A server is a physical computer that takes up space. It's running on a box, it's in a room, and oftentimes a cold room because it needs to be cooled. It takes up electricity, so servers cost money, which means if we want more servers, we gotta spend more money. Now, a server traditionally used to run an operating system, and on top of the operating system, it ran applications. Now, with this current approach, we're not optimizing on the usability of our server, and not to mention the fact that the server can only do what the apps do. Now, in order to better use our resources, as well as isolate these applications further, we came up with this sort of approach called a hypervisor and virtual machine approach. So now instead of just running an operating system, the server runs something called a hypervisor. And a hypervisor lets us run virtual machines. Now, a VM or virtual machine is a software-defined mini computer that sort of runs on top of this hypervisor thing. And these virtual machines allow us to isolate our applications further, and each virtual machine can have its own operating system. So this OS could be Windows, let's say. And this one could be Linux, and we could have other applications that run on different operating systems. And this obviously is a good approach. It's a solid beginning to working our way up to optimizing on our server, because now our server doesn't just do one thing. Our server can run Windows, our server can run Linux, and it can run, obviously, the applications that will go inside. So an app will run in here, an app could run in here. Now, we've optimized on the server's utilization, but we still have to now manage all of these virtual machines. We got to manage the hypervisor, and our management costs went up. Even though we don't need more servers, we need more people perhaps in order to further manage these virtual machines. So what we did instead is we went back to the operating system, back to this operating system here, and we said, hey operating system, how can we further segment our applications in a more useful manner and in one where we don't have so much management? Now, along comes containers, and the most famous container technology is Docker. Containers can only run on Linux machines, and the reason for that is that Docker actually utilizes two key aspects of the Linux kernel. The number one is the namespace, and the second is the C group. Now, we use namespaces in order to tell Docker and Docker containers what they can see. And C groups are used to tell it what it can use. For example, a namespace might say that you can only see these users, or this network card. And C groups might allow it to use specific pieces of the hard drive, maybe even the GPU, if you were running some sort of machine learning algorithm. And so a container is essentially just a isolated process. And that process is running on top of our operating system, utilizing the namespaces and C groups in order to create a lightweight box, a super tiny, bare bones box that will be able to run the entirety of our application. And that process will include that operating system. It will include our app as well. And so what this has done for us is that this essentially allows us to optimize on the utilization of our server. And with this approach, we can actually run a whole bunch of containers. And the way that Docker containers really help us is that they allow us to easily turn them off and turn them back on. So if we have a virtual machine, for example, virtual machines take up a couple of minutes actually to start up. But Docker containers start up in seconds. And in the software industry, containers are being used more and more. But how can developers use Docker containers for their applications? In order to utilize Docker container technology, we need to use something called an image. And an image is a template that will define what code will run on the container. In order to define our own image, we need to use a special construct known as a Docker file. And a Docker file will essentially contain all of the instructions required in order to assemble the image we need for that Docker container. Once we have our Docker file, we can use a command known as docker build in order to convert this Docker file into an image. The next command we can run is docker run. And what docker run will essentially do is it'll take this image and now it'll run it as a container. Now this is a good instance for when we want to have our own container based on our application. But if we want to use somebody else's container, for example, let's say I build my application and I want you to use it on your computer or interact with it somehow. One of the cool things that you can do that's built into the Docker ecosystem is this idea of a repository. And a repository is a sort of like database that contains a bunch of images. So we'll have a bunch of images in here, and each of these images can be called something. Like we can call this image Usama app. We can call the next one Bob app. And each of these applications, each of these images can be pulled down from the repository with a special command called docker pull. And the docker pull command will allow us to pull images from our repository onto our local operating system. And once we have the image, we can actually go ahead and run our docker run command from right here and build this image onto our computer and have it readily available as a container that we can interact with. Now, I realize I've thrown a lot of information at you, but to just sum everything up, here are the four main key concepts of Docker. I say Docker Hub here because Docker Hub is the default method of sharing your images. So if you go right now online, if you go to dockerhub.com, you'll actually find a list of images there that you can actually search through, pull down by running docker pull and then the image name, and have access to and run on your computer. Now, container technology allows us to get a lot done. We're able to better isolate and package our applications. We're able to scale them up and down. We're able to run them on different operating systems. It allows us to better utilize our servers and therefore have an increased return on investment. And it's really essential for today's developers, today's system administrators, to have a solid understanding of how Docker works and how to use Docker with the command line and how the Docker ecosystem sort of all fits together. And so concludes today's video about Docker. Hopefully you guys got a better understanding of what Docker is, what people are talking about when they speak of containers. In upcoming videos, I'll be talking about the Docker Hub, pushing and pulling from it. We'll be making our own Docker file and using our Docker image in order to spin up a container.